Hi everyone, welcome back. So this time we're going through force and weight. Woo! Or maybe not woo. It really depends on you. So, force and weight. Now here is the weird thing. Here's the weird thing. It's not that hard. You're going to think it's hard, but it's not, okay? Other classes are going to make it much harder, but this class, it's a fairly simple equation. I'm going to make you remember a couple of things. We're going to use it several different ways, but in the end, it's just a very simple equation, 3 terms. You can do this, I believe in you. So let's jump into it. So anytime you're trying to move something, or if you want to keep something from moving, you are applying a force. It's always good to think of forces as pushes or pulls. Even when it comes down to electrostatics, where you have opposite charges attracting and like charges repelling each other, they are pushing each other, they are pulling each other. Gravity pulls you down. We use those words for a reason. It's how we visualize it. Okay, now if you're moving something, then you have to change its velocity. And if it was stationary, it's not going to suddenly teleport. You have to change its velocity. It has to get moving, and it'll get to where you want it to be, which tells you something. This tells you that force is going to be connected to acceleration. The second thing you realize is that if something's really heavy, it's hard to move. I mean, it's much easier to move a child's toy than it is to move a car, at least if you're pushing. So the second thing this might tell us is that mass is connected to force. Okay, now how are they exactly connected? Well, luckily, I want to go into that. Let me click here so I can actually go through. There you go. So force is calculated using Newton's second law. You're like, what about his first and third? Take my other courses, we'll get to those. They're fun, they're great. I absolutely love them, but not right now. So the big thing of this one is object in motion stays in motion, and an object in motion, an object in rest stays at rest unless acted upon by an outside force. This is the one that tells you why it's so hard to get up in the morning. It's hard to get up because an object at rest stays at rest unless acted upon by an outside force. And I moved myself backwards, went too far. Oop. And here we go. So the equation looks like this. Force equals mass times acceleration. I put the arrows to remind you that acceleration and force are both vectors. In this class, we don't usually think about this. About the only time I'll make you think about it is if I have 2 forces that are counteracting each other. Now, what's that kind of crazy looking E right here? What is this? What's that? That's a sum. That's saying that you had to add all the forces together. So if I have 6 forces that are all pushing in this direction, well, then I have to make sure that I add them all together. If I have 2 forces that are opposing each other, I have to add them together. One will be negative, the other positive, so they will cancel out partially. And this equation tells us what we saw earlier. The more massive something is, as in it really has mass, not its volume, its size, the more force it's going to take to move it. The second thing is that all forces matter, and if they're opposite directions, then they cancel each other out. Okay, now let's look at this real quick. So I have a bunch of different cases here. I kind of divide them into 2. So the first case, what we see is we have a force. Black arrows are forces, the red arrows are the acceleration that results from that force. And we have a mass, 10 kilograms. This one right here, 2 kilograms. Now, mass is not always proportional to size. I could have something that's very empty, like a balloon. In this case, I'm making it proportional to size just to make it easier to see. What you see is that for the same force, I have 2 different accelerations. The reason the acceleration is different is because the mass is different. Force equals mass times acceleration. So therefore, if I want to solve for the acceleration, what I get is that acceleration is equal to force divided by mass. And so 10 divided by 10 is 1. 10 divided by 2 is 5. So my mass dropped by a factor of 5. My acceleration increased by a factor of 5. It works. Okay, in the second one, I'm just showing you what happens if you have an opposing force. So I have 10 newtons going to the right, and I have 6 newtons going to the left. I say negative 6 newtons. Negative signs with vectors are a little bit different. but I'm just meaning that's going to the left. So they're opposing each other. And in the end, what you see is that my acceleration is only 2 meters per second squared. Now, why is that? Well, acceleration is equal to force over mass. Okay. Mass hasn't changed, but the force has. The resultant force has. Because that would be equal to 10 minus 6 over 2. So 4 divided by 2 is 2 meters per second squared. Okay, so with this we've seen a couple examples. We're going to do more, don't worry about it, about how you calculate force. And there's a lot of other things you can do too. You can calculate mass using this. You can calculate acceleration. Be sure that you understand how to solve this algebraically to solve for anything it requires. The practice problems will walk you through this, but just in case, make sure you're doing it from the beginning. Well, I hope this helps you, and I will see you all next time as we learn about weight. Talk to you then. Bye-bye.